Okay, so with Phylum Ascomycota is also known as sac fungi. The genus it has is the Pisia, and it's a cupper base. It's the largest class, and it's free living and symbiotic. I don't know how to pronounce it. And the septate it has septate hyphae, which is it has a cell wall with Pefferionets, and the ascus/spore sac forms ascocarp. And this phylum includes yeast, mildew, molds, and truffles. And it also, one of the representatives are clavieps and red ergot. The red ergot, and it's a poison. The clavieps is the poison. And the clavieps is a genus. And so is Saccharomyces for yeast. So the clavieps is a poison for the uterine contractions, and it could cause hallucinations. And as most of you know, penicillin, which is the genus of Penicillium, is the first antibiotic that humans discovered. And this phylum also includes cheese, wine, and bread. The fermentation used for taste, alcohol, and carbon dioxide bubbles. Okay, so let's start with the life cycle of the Ascomycota. So the Ascomycota is also, it goes through asexual reproduction and sexual reproduction, as well as, if you watched my other video, the phylum Zygomycota. Okay, so let's start. So first, this one's pretty complicated to me because it's not as put together as Zygomycota, but I'm gonna explain it through talking first. So first we start, let's begin with asexual reproduction. So with the asexual reproduction, the mycelium of the condophore, it disperses. It has spores and it disperses. The haploid spores are the condia. It disperses and then it germinates. The hypha germinates, so it goes in a circle. And then, but before that, let's backtrack. Here, I think it's easier if I draw it. Okay, so first let's begin with the mycelia. That is drawn really bad. Okay, the mycelia. Then we have the from the mycelium, we get the condophore, something like that. I don't know how it's spelled. And then I do, but and then the Ascomycelia can reproduce asexually by producing pigmented haplospores. So it's gonna give off haploid spores. And then with that, it's going to germinate, and then the hypha germinates, and then we start all over again. So that is the sexual reproduction of the Ascomycota. It goes through mycelium. The mycelium then has the condospore. We have the haploid spores that come from this, and then it germinates all over again. And then this cycle and the sexual cycle of the Ascomycota, it connects. So from the germination, from the asexual, we got a negative mating type. So now, starting from sexual, we have a negative and a positive. And this negative came from the asexual reproduction, which was the spores that it gave off. And then we start the positive. So with the positive mating type, mating type, because again, it's not female or it's not male or female. Then we go through plasmogamy, which is the fusion of the cytoplasm. Plasmogamy, which is the fusion of the cytoplasm. And all from what I said, from right now, everything, even the asexual, it's all diploid. I mean, not diploid, it's all haploid. One set of chromosomes. And then after plasmogamy, we then go through the heterokaryotic stage. No, it's N plus N. So it's dikaryotic. Dikaryotic stage, which is N plus N. The dikaryotic hyphae that results from plasmogamy produce mainly dikaryotic asci, two of which of them are shown here. So we have ascus, which is dikaryotic. Let me try to draw it. I don't know. This is like the ascus. And then with this stage is N plus N, so it's dikaryotic. From this, we've moved on from haploid. So now it's dikaryotic, which is N plus N. And now we go through mitosis, which is clones, the cloning, genetically identical. And then now we go through karyogamy, which is the fusion of the cytoplasm. And now we are going to diploid. From karyogamy, we're going to diploid. So now we have a diploid nucleus. So now we have, let me not do that. Let me put diploid nucleus. Now we have a diploid nucleus, which is now making the stage diploid. But in Ascomycota, it doesn't stay diploid for very long, for a short amount of time. And then now we go to meiosis, which is genetic variation, and this is a zygote. I probably spelled it wrong. 2N. And then after the meiosis, we are now haploid again, so 1N. And then from the meiosis, from this now, we have 4 haploid nuclei. So 4 haploid nuclei. And with these 4 haploid nuclei, each diploid nucleus divides by meiosis. So from the karyogamy, it's dividing, and it becomes 4 haploid nuclei. And then with that, it then goes through mitosis to produce the 8 ascospores. Let me write this. 8 ascospores. So each haploid nucleus divides once by mitosis, yielding 8 nuclei. Cell walls and plasma membranes develop around the nuclei, forming ascospores. So from here, from the mitosis, it's dividing into 8, just like this. Now, from the meiosis, it divided, it broke apart into 4. Now we were going into 8. And from that, the ascospores are discharged forcibly from the asci through an opening in the ascocarp, germinating ascospores to give rise to new mycelia. So now we have the ascocarp. Which looks like this. It's like, I don't know. And then it's giving off the spores. This asci, just like that, like the little spores in the mycelia. Yeah, that little the ascospores. So these are ascospores. And then from the ascospores, let me write it again here, ascospores, it then germinates. It goes through germination and dispersal. Okay. Dispersal. Right. Let me draw a little bit more of the spores, and then we go through it again. And with that it produces new mycelia. And this is the sexual reproduction now of the phylum Ascomycota. Let me write it here in the middle. Sexual reproduction of phylum Ascomycota. Just like that. There we have it. I could put a picture in the end for you guys to see it better, but this is how I'm studying it. So yeah.